Today we're talking about a really important concept for calculus called the slope of the tangent line. So first off, we need to figure out what is a tangent line. So a tangent line is a line that touches your curve at exactly one point. So this is my curve, my parabola. My tangent line is going to touch my graph at exactly one point. So this is my point. My tangent line would just touch that curve just at that one point. So if this is my point, here would be my tangent line. So I want you to notice both of the slopes of these tangent lines are negative. And as I get closer and closer and closer to my vertex, my minimum, my slope is getting less steep. So it's still negative, but then once I get to the vertex, my tangent line has now become horizontal, and the slope of that tangent line is now 0. So here, the slope of my tangent line was negative. Then once I hit my vertex, the slope is 0. And then if I kept picking points on the right side, well, now the slope of my tangent line is positive. So depending on which point you pick on your curve, the slope of the tangent line will be different. So it's clear to see that over here the slope is negative, over here the slope is positive. So depending on which point you're choosing, the slope of your tangent line will change. So first one, what is the slope of the tangent line of y equals 2x minus 3? Well, that's just a line. It has a y-intercept of -3. It has a slope of 1. So no matter what point I choose on this line, the slope of the tangent line, sorry, I should use a different color. The slope of the tangent line is going to be the same as the slope of your line itself. So since the slope is constant for this line, that means the slope of the tangent line at any point on the line will be the same as the slope of the line. So the slope of the tangent line is 2. So for more complicated problems, the slope of the tangent line at any point can be found using this equation. It's a limit. This is a formula you're going to have to memorize. It's the limit as delta x means the change in x, as the change gets smaller, as it approaches 0. The limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So right now that looks really scary and intimidating, but the more you use it, the easier it becomes. But you do need to have this formula memorized. It's important that you realize this is negative, this is positive. People sometimes flip those, so there's little mistakes that you can make that can wreck your whole problem. So make sure you really have this formula memorized. This is how you find the slope of the tangent line of any function at any point. So our first example is find the slope of the tangent line. Whoa, sorry. Click the button. Find the slope of the tangent line of our function f of x equals, equals x squared plus 1 at the point -1, 3. Because remember we talked about, depending on which point you choose on your function, the slope of your tangent line is going to be different. So we're trying to find the slope of the tangent line at this specific point, -1, 3. So first thing we're going to do is we're going to use that formula. So I'm going to copy down the formula. The limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x, just to help me remember the formula. What this means is I am going to go plug x plus delta x into my function. I'm going to plug x plus delta x in for x. I'm going to have to use parentheses. So the limit as delta x approaches 0. And this is going to be all of this is going to go in here. Okay, so I'm going to have x plus delta x in parentheses, and I'm going to square it, plus 1. Then I'm going to subtract f of x, this whole thing. So I have to use parentheses or brackets. Whatever, it doesn't matter. Brackets or parentheses, whatever. Over delta x. So remember, what I did was first to find f of x plus delta x, I went and took x plus delta x and plugged it into my function for x. And then I subtracted the original function. So what I'm going to have to do now is FOIL x plus delta x. So this is the same thing as x plus delta x times x plus delta x. So I'm squaring it. And plus 1. And then I'm going to distribute the negative to both of the terms inside the parentheses. So, excuse me, negative x squared minus 1. So I have to distribute that negative to both terms inside the parentheses, all over delta x. Okay, now I need to FOIL this out. So I will limit delta x approaches 0. So foiling this, x times x is x squared. X times delta x is x delta x. And then x times delta x. So this is 2x delta x. And then delta x times delta x is delta x squared. And then plus 1 minus x squared minus 1. All over delta x. So lucky for us, a couple things are going to cancel out. I see I have a positive x squared and I have a negative x squared. They're going to cancel each other out. And then I have a positive 1 and a positive 1 and a negative 1, and they're going to cancel each other out. So now I'm left with the limit as delta x approaches 0 of 2x delta x plus delta x squared over delta x. Oh, sorry. So if you notice, we have a delta x in both of the terms in my numerator, and I have a delta x in my denominator. So what that means is I can divide a delta x out of each of these terms. So I'm going to have the limit as delta x approaches 0. I'm going to cancel a delta x out of my numerator to get 2x, and cancel a delta x out of x delta x squared to get just delta x. So when I'm evaluating limits, remember you can't have 0 in your denominator. So that was always kind of the problem with this, is I had delta x in my denominator, so if I was going to go plug 0 in for delta x, I'd have 0 in my denominator. Well, now that I've reduced this and my delta x in my denominator has canceled out, I'm just going to go plug 0 in for delta x. So this will be equals 2x plus 0. I went and plugged 0 in for delta x, and now I'm just left with 2x. So this represents the slope of the tangent line at any point on that curve, on any point on that parabola. However, our problem specifically asked us for the slope of the tangent line at the point -1, 3. So what we're going to do is we're looking for the slope of the tangent line at -1, 3. My x value is -1, so I'm going to go plug -1 into that. So 2 times -1 is -2. So the slope of the tangent line at the point -1, 3 is -2.